All right, guys. So here's what we were having issues with. Hopefully by now you're not. I mean, I know some of you already finished it, but so let's just go over some questions that we were kind of having issues with, and I'll make up some problems as well in a little bit. So look at example 1 here. The first thing you're going to always try is direct substitution. So on this one, notice as long as you don't get a 0 in the denominator, can I do direct substitution on letter example 1, part A? Yes. So direct substitution, 2 minus 4 over 2 squared plus 2 plus 2. So let's see. Negative 2 over, let's see, 4 plus 4. So negative 2 over 8. So negative 1/4. You can be more efficient than that if you wanted to. Are we okay with that? Okay. On example B, you cannot do direct substitution because you get a 0 in the denominator. See, 3 squared minus 3. 3 squared is 9, minus 3 is 6. 6 minus 6 is 0. So remember what I told you guys. If you do direct substitution and you get 0 over 0, it's more than likely going to have a limit. Not always, but more than likely. There are times where it does not. So I get 0 over 0, so that means I got to try something else. So here we go. I'm going to put it to blue so you can differentiate it from that red. Limit as x approaches 3. The numerator is the difference of squares. Now, some of you, I've been seeing you guys do these questions on Delta Math, and you don't write the word limit in the front. You just do the algebra. So be careful when you're doing free response questions. It's all about correct notation. Write the word limit in the front unless you already evaluate it. Does that make sense? In the bottom, I have to factor out two numbers that multiply to give me negative 6 that adds up to a negative 1. Yeah, 2 and 3. Which one's going to be positive? Which one's going to be negative? So x minus 3, x plus 2. Multiplying and dividing are inverse operations. I have a product in the numerator, I have a product in the denominator, and I have this divisor here. So what factor is going to cancel out? X minus 3. So I come over here, I do the x minus 3s. Now that I've canceled out the x minus 3s, now can I do direct substitution? Yes. What's 3 plus 3? What's 3 plus 2? 5. If they were to ask you, how does this function look? You have a hole at 3 comma 6 over 5. So that's a hole, guys. You have a vertical asymptote, VA, at x equals 3. Why do you have a vertical asymptote? You have a vertical asymptote at x equals negative 2. Sorry about that. Just saw that. Why do you have a vertical asymptote at x equals negative 2? Because that's the factor that did not cancel out. Is that making sense? Okay. So this is just extra because something's coming pretty soon. All right, look at this question right here. Ask me, guys. Did I explain everything clearly, or are you sure? Yeah. Okay. Look at this one right here. Can I do direct substitution? No, but notice you get a number divided by 0. You can't do that. So this one is going to go right off the bat. You're just going to say does not exist. If you get a number in the numerator and 0 in the denominator, it's automatically a vertical asymptote at x equals 2. That's a VA, vertical asymptote. The VA stands for vertical asymptote. If you get this x plus 3 over x minus 2, if you were to graph it, would look like this. 2, and let's see, positive. Actually, you have a horizontal asymptote of 1. If you were to graph this, it would look like this. See, like that. Because remember what I told you in yesterday's notes. If you do direct substitution, you get a number in the numerator and a 0 in the denominator, right off the bat. You don't have to do any more thinking. It's a vertical asymptote. You can't divide by 0. If you do, you win the Nobel Prize. You won't win the Nobel Prize, guys, because you can't divide by 0. Okay. Tough crowd. Are we understanding what we're doing, guys? Okay. I think you guys are pretty good at that. Okay, look at letter D. Again, I can't do direct substitution. You get a 0 in the denominator, but you get a constant in the numerator. You get a 5. So this one also does not exist. Can you close the door? The only difference between C and D, I want you guys to notice this. Check it out, Galore. You see how letter C looks like this? On letter D, it almost looks the same as this, right? But it doesn't have you see how it's a square? So on letter D, this one down here is up here like that. And they both approach positive infinity as you approach 2 from the left and the right. Because you're squaring the denominator, and it'll never be negative. Any negative number squared turns to a positive. Yeah, you see that? Okay, so make sure we're aware of that, guys. And I know some of you might have issues with this because of your algebra. If your algebra is weak, that's what we're going to have trouble with. Calculus, the concepts for calculus are simple. It's the algebra. As this approaches infinity, hopefully we're getting good at these specifically. What is this? Yeah, say it. Say it loud and proud. I heard you. That's correct. 3/2. End behavior. Spit in the ocean. That 5, you only do this as x approaches infinity. That 5 is like spit, so my end behavior for the numerator is 3x. In the denominator, that 4 is like spit, so my end behavior for the denominator is 2x. 3x divided by 2x, x's cancel out, and it's just 3/2. Do you guys see what we're doing? Okay, look at letter F. 4x plus 7 over x squared minus 3x plus 5. This is going to equal 0 because the denominator is growing faster than the numerator. Are we okay? I'm pretty sure we are really good at graphs. So I think you guys are really good at this. So as x approaches infinity, this is going to approach. Yeah, -3. End behavior for as you approach, as x grows unbounded to the right side. As x approaches negative infinity, the y value is going to approach 0. It's this one, right? It's this one. As x approaches negative infinity, the y value approaches 0. All right, letter C. As x approaches -3 from the left, so here's -3. If I approach -3 from the left, what is this y value approaching? Infinity. As x approaches -3 from the right, what is that y value approaching? Negative infinity. Good job. Gonzalez, how do I say this limit? I'm not picking on you, miss, I promise. Oh, no, this is Gonzalez. Oh. Yeah, sorry. There's another Gonzalez in here, guys. Sorry. All right, Annabelle. Okay, so if I approach 0 from the left of g of x, what is that limit? 0. We don't care that there's a hole there. We just care about where we're approaching. Are we still okay? Okay. Let's see. Bias. Can you read this line for me and then hook me up? Okay. As I approach 0 from the right, what is that? Infinity. Good job. Positive infinity. See, I think you guys are really good at this now, so I don't think we have issues. Limit as x approaches 4 from the left. I approach 4 from the left. Infinity. Limit as x approaches 4 from the right. Infinity. I want you guys to notice really fast. Letter E, letter F. Notice as x approaches 0, x approaches 4. I have vertical asymptotes at x equals 4. And I have a vertical asymptote at x equals 0. But I want you to notice, I just want you guys to observe, that as x approaches 0 from the left, that was a value. See this one, letter D, that x approaches 0 from the left, that was 0. But look at letter E, limit as x approaches 0 from the right, that was infinite. So you don't, just because you have a vertical asymptote of 0, does not mean, if it's a piecewise function like this one, it's possible that one side will converge to a number, as long as one of them doesn't converge, as long as one of the sides doesn't diverges, I guess is the word, as long as one of them goes unbounded, positive infinity, negative infinity, the y value, then it's a vertical asymptote. So even though this one on the left, from the left is converging at y equals 0, it's still a vertical asymptote because from the right, it's approaching positive infinity. Does that make sense, guys? Okay. So the next page, these are the questions that we were having trouble with. And don't worry, we're going to stop here. We're going to cut this into 2. I think I'm really excited for, well, we'll see. Look at the tougher algebraic limits. Can I do direct substitution on letter A? No. You also notice that if you do direct substitution, you get 0/0. -2 raised to the third power is -8. And -2 plus 2, did I say -8? Oh yeah, it is. -8 and -8 plus 8 is 0 in the numerator. In the bottom, -2 plus 2, that's also 0. 0 divided by 0, it probably has a limit. By the way, this has a name. In case you want to know, don't ever equal this to 0/0. Just put it on the side. This has a name. This is indeterminate form. Indeterminate form. So when you talk to your professor, you say, oh yeah, this is of indeterminate form. That's what you say. Are we okay, guys? All right, here we go. You have to recognize that this is the sum of cubes, and I'll write the sum of cubes here. A cubed plus B cubed from your algebra day, that's A plus B. A squared minus AB plus B squared. They're pretty easy to remember or to memorize. The one that has the sum of cubes starts with a plus, and then just make the middle term right here in your trinomial minus. And then you got the A cubed minus B cubed. That you call the difference of cubes, and that one's going to start with a minus, so A minus B. There's a binomial. That binomial just means 2. And then your trinomial, you're going to make them all positive. A squared plus AB plus B squared. Are we okay? All right, so this right here, your A is like x times x times x, and your B on this one is like 2 times 2 times 2. So here we go, limit, because we haven't evaluated it yet, as x approaches -2, of x plus 2, close, open, x squared minus 2x plus 4, close, that 4 came from 2 squared, over x plus 2. Are we okay? Are we okay, guys? Okay, now some of you, remember guys, I've been seeing a lot of you do the work on delta and you don't write the word limit. Make sure that you put the word limit until you've evaluated it. Now we're evaluating this. What can I cancel out? Now that I've canceled out the x plus 2's, now you can do direct substitution. So let's see, -2 squared and then plus -2 times -2 is a positive 4 plus 4. So this looks like 4, 8, 12. This looks like 12. So there it is. Do you see how we're doing it, guys? Okay. Letter B. When you get to letter B, and I think delta now has both methods, method 1, method 2. What's making this hard is the numerator, right? That's what's making, that's what looks pretty tough. So you can either multiply this by the conjugate, square root of x plus 2 over square root of x plus 2. That's kind of like the difference of squares. And notice that I said that's kind of like the difference of squares. Or you can recognize, look at this. Square root of x times square root of x is x. 2 times 2 is 4. And okay, I don't know if you're ready for this, but I'll tell you. If you're subtracting 2 terms, you can always do the difference of squares. The difference is it's not a perfect square. Chad, what are you talking about? So I'm just going to make this up. Just here on the side. I'll put it here in the margin. You don't have to write this, just observe. If I were to write something like x to the 3/2 minus, 5. You can always do the difference of squares. It's just not a perfect square. Oh, child, I don't know how do I get that? Well, look, x to the 3/4 times x to the 3/4. That gives me x to the 3/2. 3/4 plus 3/4 is, what's that, 6/4, and 6/4 reduces to 3/2. Do you guys see that? And then what about that 5? Square root of 5 times square root of 5. So look, I can write this as x to the 3/4 minus square root of 5, x to the 3/4 plus square root of 5. So when they say difference of squares, it does not have to be a perfect square. Obviously, a perfect square is the easiest, right? You can see it. But when they say difference of squares, it does not have to be a perfect square. So hopefully we're blowing your mind. If you're subtracting any 2 terms, you can always do difference of squares. Notice here, square root of x and square root of x and 2 times 2, they're kind of being nice to us. So we're going to write this as limit, as x approaches 4, of the square root of x minus 2 in the numerator. And in the denominator, I'm going to write square root of x plus 2, square root of x minus 2. And now that I did that, what can I cancel out? Yep, out. Now I can do direct substitution. I have a 1 in the numerator. Square root of 4 is 2, and 2 plus 2 is 4. Child, what did you do? I just did direct substitution, guys. I plugged in the 4 into what I have left. Is that making sense? Okay. Are we still okay, guys? All right, look at letter C. Don't worry, we're going to stop right here at letter E right there. Limit as x approaches 0 of the square root of x plus 16 minus 4 over x. Can I do direct substitution? No. What is making this tough? The numerator or the denominator? The numerator. So you're going to multiply this by the conjugate, square root of x plus 16 plus 4 over square root of x plus 16 plus 4. You're just changing the polarity of that 4 there, guys. That's what conjugate means. Why are we doing that? Because this is like the difference of squares. Look, that's a minus b, a plus b. So you don't have to worry about the middle terms. Chop, what are you talking about when you say middle terms? Okay, just observe. Don't write this down. Just look. A minus b, a plus b. When I multiply a times a squared. That's an arrow there. A squared. A times b plus ab. Negative b times a minus ba. Negative b times a positive b minus b squared. Look, these middle terms, they zero out. AB is the same as BA, they zero out. If you wanted to write AB minus AB. And then look, you just have A squared minus B squared. So I don't have to worry about the middle stuff. Does that make sense to you guys? When I say middle stuff, I'm talking about like this that I crossed out. So I'm going to write limit as x approaches 0. And I'm going to write giant parentheses, square root of x plus 16 times square root of x plus 16. That's just x plus 16. And I don't have to worry about doing FOIL, because it's kind of like the difference of squares. Negative 4 times a positive 4. Minus 16 all over x, and then don't distribute this, just leave it like this. Square root of x plus 16 plus 4, close parentheses. That's my parentheses here for this. And then close the giant parentheses. Are we still okay? All right. Tell me, guys, because I can't read minds. Are we okay? Okay. What about these 16s? What do? They cancel out. They zero out. Now that you canceled out those 16s, now that you zeroed out, you just have one little term in the numerator, an x. And look at the bottom, it's a product. X times this. What can I cancel out? The x's. We can say now that you can say that. You can cancel them out, though. Cancel, there it is. Now I can do direct substitution because I no longer get a 0 in the denominator. Do you guys see that? So 0 plus 16 is the square root of 16. And 4 plus 4. Make sure you put the 8 in the denominator. Some of you guys are writing 8. It's in the denominator, guys. Are we okay? Trav, how do I do letter D? Okay. Yes, you can always use Desmos, but I really want you guys to think about this critically. Relax. If x is bigger than 0, so I'm just going to pick some numbers. This is absolute value of x over x. So that's like saying y value equals absolute value of x over x. That's what that's a function. Y equals x. I can think of it as f of x as well. That's an absolute value, not a parentheses. I did a bad job with my absolute value. I said absolute value, but it looks a little curvy. All right, I'm just going to choose random numbers bigger than 0. If I choose x equals 1, 1 divided by 1, 1. If I choose x equals 5, 5 divided by 5, 1. If I choose x equals 10, 10 divided by 10, is it always going to be 1 to the right of 0? Yes. Here's 1, open circle, right forever. Now let me choose numbers to the left of 0. Absolute value means it's going to stay positive, right? So if I choose a number like negative 5, I'm going to have a positive 5 on the top divided by negative 5. Positive 5 divided by negative 5, what's that? Negative 1. If I choose negative 10, so positive 10 divided by negative 10, what is that? Negative 1. So everything to the left of 0 is always going to be negative 1. It goes like that forever. Okay, now that you know that, as x approaches 0 from the left, what is that limit? As x approaches 0 from the right, what is that limit? Do they match? So what am I going to say for this one? Good. Does not exist. Is this helping, guys? Okay. How do we feel? All right. I'm going to go ahead and stop it here. We'll do letter E during 6th period. Is that okay? Relax. It's not that it's difficult. It's just that I kind of want to simplify it, and so I don't want to do it right now. I'll do it after lunch. Is that okay with you guys? All right. All right, guys. Let's do the notes first. Okay, here we go. So we left off on this one. And what's making this one not being able for us to do is that we get a 0 on this rational part right there. So go to the side, and you can see why factoring is so important. And I'm going to write x minus 2 over, and on the bottom, two numbers that when you multiply give you negative 2 that adds up to a positive, that adds up to a negative 1. 1 and 2, and the negative 2 is negative, and the 1 is positive. The negative 2 is negative. The 2 is negative and the 1 is positive. Are we still okay? Now these two cancel. Bam, bam. And now I don't get a 0 in the denominator, so I'm going to rewrite this. Limit as x approaches 2 of 3 to the power x plus sine pi x. Why am I writing? Sine pi x all over x to the power 4 plus 1 over x plus 1. Are we still okay? I no longer get a 0 in the denominator, so now we can plug in. So let's plug in that 2. 3 to the power 2 plus sine 2 pi over 2 to the power 4 plus 1 over 2 plus 1. And you are done with calculus. Now you're just doing arithmetic. Relax. It's not even that bad, miss. Arithmetic. Here we go. What's 3 squared? 9. What is sine of 2 pi? 0. Yeah, 2 pi is right here, the y value, so 0. Over 2 to the power 4. Let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is? So 16 plus 1/3. If this were the AP exam, I would tell you to leave it alone. But this is not the AP exam, so we should probably practice solving. What's up? That's a 0. It looks like an 8? Yeah. Guy that said sine of 2 pi was 0. Oh. Yeah, see, don't be a robot. You're just writing down. Make sure we're listening. Okay. Thank you for asking. 9 over, what are you going to do? I'm going to multiply that 16 by 3. 16, 32, 42, what's that, 48? 48 plus 1 is 49. Are we still okay? Keep, change, flip. 9 times 3? 27 over 49. Does that reduce? No. Sorry, it took me a while. Yeah. For the 16, you divide first, then you add it. For the what? How did you do the bottom? The 14. I did 16 times 3 over 3. Okay. Ask me, guys. The delta math, you can ask me anytime. It's a UH that you can't ask me when you're live because, the delta math is supposed to be like skill practice, and then the UH is testing to see if you mastered the skill. So on UH, ask me after the fact. Like once you've taken it. I am going to try. Okay. I am going to try something different. Yeah. Dean, tell me if you think this is going to be perfect. I think it's going to work out. I'm going to start doing something. I just thought, I don't know why I haven't done this in the past. So I'm going to start giving you guys a grade for doing notes for the UH quizzes. But don't worry, it's a free 100. And what I'm going to do is I'm going to post, here's what I did with pre-cal. I'm going to give you one of these, like an old one of someone that already did it. And how last year I would tell you guys to come in after school or sometimes, okay, I'm just going to post it on Canvas already. And I'm going to say, all right, do the notes. That way you can, what's the whole point of notes? You can reference it. So you do the notes first. And then once you do the notes, you take the quiz. Mm-hmm. And don't you think that will at least eliminate how do I do this? How do I do that? Because now you're going to see it first before you even do it. So wouldn't that be cool? And I don't know if you noticed, but have you noticed that the UH quiz for calculus is not cumbersome? It's not like 20 questions like it was for the pre-cal one. Yeah. So and that's how all the calculus ones are. I think the shortest one is 8 questions, the longest one is 12 questions. The only ones that are long are the ones that say UH test 1 or UH test. If it says UH test, those are long. But you only have 2 of those, and it's 1 per semester, so you'll be fine. See? Okay, what's up, Gonzalez? You'll be fine. You'll be fine. Everyone else has been fine. Oh, I'm so excited about a question in a little bit. All right. So look at this question here. Hopefully by now you guys are legit. This is coming from the CED, the course and exam description. Take 30 seconds, and I know that I didn't do a poll. I need to start doing that. Eventually, I'll eventually do it. Hopefully this coming week. Take 30 seconds, see if you guys can figure this one out, and then we'll talk. Look, I have it right here. See, I got ready, miss. We're good. First, you do this. Limit as x approaches 1 for g of x. What is that limit? 2. And then you're going to go limit, even though you're not defined at 2, you don't care about the where you're defined because we did limit. And you're going to go limit as x approaches 2 of, and what is that? Okay. Is everyone good with that one? Okay. Now check this out. And I'm so proud of this question here. In 2000, I want to say it was 2016. This is coming. So let's say some of you may not be getting super confident as you should, but let's look at a special problem where only, okay. So let me talk to you about this question. I want to say it's 2016, sorry. Only 9% of the BC population got this question correct. BC kids are supposed to be the best of the best. That's why the BC calculus exam has a really high passing rate. You got to be a mega nerd to be in BC. Sorry, Dean. Okay. The hardest question in BC, it wasn't a Lagrange error, because that tends to be pretty hard for BC kids. It wasn't a series question. It wasn't an error bound or a Taylor polynomial. It was a limit problem. Only 9%. This was the hardest question in that exam on that year. It was a limit question that was the hardest question. Let's see if you guys can get it at a higher passing rate than 9%. Take a minute or two and see if you guys can get it right. And it's okay if you get it wrong, but let's see if you guys can get it right. How many of you think the answer is A? No? Okay. How many of you think the answer is B? Okay, I see 2 of you, so I'm going to put the number 2. How many of you think the answer is C? Yeah? No? Okay, 1 of you. Okay, 2 of you. How many of you think the answer is D? How many of you think the answer is E? 1, 2, 3, 4, 5, 6. 6 of you. 6, 7, 8, 9, 10. Guys, there's 17 of you guys. What about the other 7? Okay. All right. Let me see. Let me look at it. 1 minus x squared. 1. 2 of you got it right. Well, I don't know. I mean, I do know. But. All right. I'm going to tell you guys how to do it. Oh, Ms. Dina, do you want to explain how to do this one? Do you remember this one?
She's still AB, so it's okay if you don't.
No, she's MBC. She already did this. Does everyone know how the graph 1 minus x squared looks like? No? It's a parabola opening downward with its vertex on the y-axis. It's just shifted up one unit, right? Guys, see, this is why algebra is important. Algebra is what's going to be the death of you guys, not calculus. It's algebra. So there's 1, and it opens downward. Do we know that? All right. Remember when we did these questions in in delta, 1 minus x squared, if you approach, so first you're going to go limit as x approaches 0 for 1 minus x squared. And yeah, that limit is 1, but notice that I'm approaching 1 from the right and the left, and then that's the highest. So that's a max, remember? That's a max. So it's like approaching all the other values of y are smaller than 1. All the other values of 1, like the y value. You're bounded by 1. So this is like approaching 1 from the left. So I'm going to write limit as x approaches 1 from the left of f of x. If I call this, well, there it is. That's my f. Is that making sense? Galore, is that making sense? Yeah, it's a max, guys. All those numbers, all the y values are smaller than 1. So it's like you're approaching 1 from the left. Where did I write it? Right there. One from the left. So if you approach one from the left, here's one. If I approach one from the left, what value am I approaching? 3. Relax. BC thought it was hard also. Cool or not cool? No. Cool. All right, guys. Relax. This one is quote unquote tough, but not for the same reason. It says given f of x equals cosine x and c equals pi over 6, determine whether this limit exists and give the value if the limit does not exist. Okay, so here's what they want. Ready? So I'm going to rewrite this. I need f of pi over 6, and I need f of pi over 6 plus h. So, and then by the way, f of x is cosine x. Are we still okay? So here comes pre-count. We're going to have a quiz, your first quiz, a quiz on unit circle starting Tuesday. We'll take one every day in lab, the first 15 minutes. Relax, you'll be fine. You guys have done this many times. Yeah, the first 3 don't count. No, well, because you guys already have experience. So, all right. What's cosine of pi over 6? Good. There it is. I also need cosine of pi over 6 plus h. Chop, how am I supposed to do that? I don't know. Do you remember cosine A plus B from your pre-cal days? What was it? Cosine A, cosine B, minus. There you go. That's called the composite argument property of cosine. From that is where we derive the double angles and the half angles. All right, here we go. I'm going to write cosine pi over 6, cosine h, minus sine pi over 6, sine h. So here comes the pre-cal. So all that, f of pi over 6 plus h is nothing more than, what's cosine of pi over 6? So then I write cosine h minus what's sine of pi over 6? And then I write sine h. So here's the limit that they want. I'm just rewriting this limit in terms of cosine and sine. They want the limit as h approaches 0. H is just like x. It doesn't matter. If you want to change the h to an x, that's fine as well. Square root of 3 over 2 cosine h minus 1/2 sine h. That's a half. It just came out. 1/2 sine h. Minus square root of 3 over 2. All this is over h. That's what they want. The 2 formulas that you know, I'll put it over here. You know 2 formulas. You know the limit as h, x. We said x. As x approaches 0 of sine x over x. We know that that limit is 1. You can put a happy face x and then happy face x if you want, but it doesn't matter. And you know the limit as x approaches 0 of, let me see, how's this one going to look? It's going to look like this. Cosine x minus 1 over x is equal to 0. You know that. You could also have the 1 in the front, 1 minus cosine x if you wanted to. Are we still okay? All right, so here we go. I'm going to go slow. I'm going to move these 2. Since there's no equal sign, you're going to keep the sign. So I'm going to write limit as h approaches 0. Square root of 3 over 2 cosine h minus square root of 3 over 2 minus 1/2 sine h. All this is over h. So get up to here, and I'll slow down. I'm going to factor a square root of 3 over 2 on these first 2. Right, let me highlight it. On these first 2 right here, these 2 terms. Ready? Limit as h approaches 0. There's my square root of 3 over 2, factored out. Parenthesis, cosine h minus 1, close it, minus 1/2 sine h. And all this is over h. Are we still okay? Okay, so let me wait for you guys to catch up. Yeah, In a little bit, maybe take a picture of this, put it on Instagram, say math life, get on my level, or don't talk to me. That way you don't get random messages from people. If they don't understand this, don't talk to them. All right, ready? Here we go. Here we go. You guys ready? You see how I'm dividing by a single h right here? So we're just doing algebra. We can always do that. So I'm going to write, let's see, what am I going to write? I'm going to write here. Limit as h approaches 0. And I'm going to write square root of 3 over 2 cosine h minus 1. All this is over, by the way, that's parentheses. All that is over h minus limit as h approaches 0, 1/2 sine h over h. We're almost done. We're almost done. This is a constant. That's a constant. Using your properties of limits, I can move that constant to the outside of that limit. So I'm going to write it like this. Square root of 3 over 2, so the equal sign, limit as h approaches 0 of cosine h minus 1 all over h minus, I'm going to move that half to the front, limit as h approaches 0, that's an h, of sine h over h. We are so close, so catch up to there. Do you see it? Yeah, you see it. Do you see it? Oh. Look at this one that I'm circling right here. Yeah, look, that's just this. That's just this right here, guys. It doesn't matter what you call it, h or x or t or whatever. It's still a variable. That I just circled is just what? 0. So I have, let me put the equal sign here. I think I can fit it. Square root of 3 over 2 times 0 minus, that minus is this minus. Notice, look at this right here that I'm circling. What is that? It's a 1 from this. It's a 1 from that. So I have minus 1/2 times 1. So my final answer is just negative 1/2. So look at all that work. You should take a picture and put it on Insta. I think that's worthy. Maybe I'll even give you a bonus or something. I don't know. But you gotta leave it there. You can't just take it on the main one. Come on, guys. No, don't take a picture of mine. Take a picture of yours. I don't want to see mine on Insta. Chubb, where will I see my bonus? You'll see on front line, you'll see a column that says bonus. And don't be fake. Don't be fake and put it on Insta just for a week or a day or two and be like, yeah, post it. That's the whole point. Anyone can post it for a reel. Well, they all add up, you know. I'm gonna add 5 to an assignment, but it has to stay there. It has to stay posted. You gotta put hashtag mathlife, hashtag get on my levels, hashtag calculus, whatever. But it needs to be your like your account, your notes. If you want, tag me and I'll see it. Or just take a screen capture that you did it and send it my way to my email. It doesn't matter to me. Whatever you want it to be. Oh, I don't care, miss. All right, let's keep going. It's 1:15. Don't worry, you can do it later on. I already said a whole bunch. Just don't worry. All right, let's go back. This right here is not tested on AP. But it doesn't mean that your professors don't want you to not want you to know this. It doesn't mean that your professors are not going to test you on this. They want to know if you know this. This is still done at most universities. It says for the following limit, find the largest. This is called an epsilon. No, actually, that one's the delta. This one's called the delta. It's a lowercase. And this one's called the epsilon. That's a lowercase delta. Are we okay so far, guys? Okay. It says and so this is like, this little e there, or this epsilon, this is like error. So it says for the following, find the largest delta that works for epsilon equals 0.01. So they want to know, how close do I have to get to 2 that the error will be 0.01 away from 2/3? So let me say it again. Guys, when you read this question, so it says, how close does x have to get to 2? Well, actually, I'm giving you more detail. How close does x have to get to 2 for my error to be 0.01 away from 2/3? So don't worry, we're going to get started. You guys ready? I'm actually giving you more than what this question requires. So here we go. So first, let's talk about error. So I'm going to write absolute value of x over 3 minus 2 over 3. Close it. And I want this error to be smaller than 0.01. That's what they want. So when you read a textbook, that's how you're going to do it. Are we okay? Okay. So now they're being nice to me. UH is going to be nice to you because all the UH problems are pretty straightforward like this. They're not all straightforward. They're not all straightforward. If you go to MIT, you go to a nice university, they're not going to be this nice. X minus 2 over 3 less than equal to 0.01. I'm going to multiply that sucker by 3. Absolute value of x minus 2 less than equal to 0.03. Yeah, because it's a 0.1, so 0.01 times 3 is 0.03. Are we still okay? All right, so you can stop right here. Stop. That's the answer they want. So the answer they want is 0.03. So 0.03 is letter B. But the answer that your university professor probably wants, move the 2 to the other side. So x has to be between 2.03 and 1.97 for the error to be 0.01 away from 2/3. Okay, say it. Ask me. Yeah, this is the answer that your professor is probably going to want. Like, how close do you got to be to x for the error to be 0.01? Oh, as long as x is between 1.97 and 2.03, the error is 0.01. That makes sense, Granados? Or are you just nodding just as nod? Okay. All right. Not tested on AP, guys, but that's going to be on your UH quiz. All right, here we go. Hopefully with these, you guys are beasts now. So then we'll have a sandwich theorem, and then we'll finish it off with the activity. All right, look at this. You guys are going to be fast now. So this one, 2 minus x. All right, guys, focus. This 2 minus x is for x less than equal to 1. That x over 2 plus 1 is for x greater than 1. So you guys know which one's coming from the left, which one's coming from the right. X less than 1, that's from the left of 1. X greater than 1, that's from the right of 1. What is the value as x approaches 1 from the left? So if I approach 1 from the left, which am I going to use, the top or the bottom? The top. Just do direct substitution. What is 2 minus 1? There it is. Do you see how we did it, guys? Okay, look at the one on the right. What is the value as x approaches 1 from the right? Which one am I going to use? The bottom. 1 over 2 plus 1. What is that going to give you? 1.5, which is 3 over 2. Are we okay? Okay. Go to the next one. What is the limit as x approaches 1? What are you going to tell me? Why does it not exist? The limit, okay, yeah, you said it right, but you got to make sure that we use correct mathematical language and notation. Limit as x approaches 1 from the left does not equal the limit as x approaches 1 from the right. Therefore, the limit does not exist. Does that make sense? Okay, perfect. This one, does this say the word limit? No, it just wants to know what f of 1 is. We come back. This is a function. It's just in pieces. And we say, where is 1 evaluated at? Which one do I have to use, the top or the bottom? The top, because that's the one that has the equal sign. Do you guys see that? So f of 1 equals 1. So we come back and we're going to circle 1. Yes. Well, yes. Cool. Okay. No, we're good. Keep asking. All right, do you guys feel okay, guys? All right, here we go. Last one. This is called the squeeze theorem. Sometimes they call it the sandwich theorem. Oh, why? Let me show you why. And don't worry, from this, we're going to go right to the 2 questions that you guys had. Notice, look what they did. Notice they put a positive x squared on the top here, and they put a negative x squared on the bottom here. So this one right here is x squared. This one right here is negative x squared. I guess I should say y equals. Job, why are they doing what they're doing? It's called the sandwich theorem because notice that x squared times sine 1x oscillates between the top and the bottom. Do you guys see that? So here's what they're doing. What they're really doing is this. They're going to go sine of 1 over x. Okay, so let me I put the square there. So the biggest, let me slow down, see if I can explain it right. You see how this x squared is on top of that sine of 1 over x? Remember when you guys were in pre-calc and we said if there was a number in front of that sine over x, we called that something, it starts with the letter A. Do you remember what we called it? We called it the amplitude. Perfect. See, so you guys are good. The biggest this will ever be, this is x squared is like, no, relax. Well, okay, let me slow down. When you had 3 sine x, the biggest this wave will ever be is, the smallest this wave will ever be is, okay, so this x squared, I know there's something funny happening because of that 1 over x, but this expression, x squared sine 1x, the biggest it'll ever be is whatever x squared is, because it's like a magnitude. So the biggest it'll ever be, so let me write sine 1x, the biggest this will ever be is x squared. The smallest it'll ever be is negative x squared. So sine of 1 over x is somewhere in between negative x squared and x squared. Do you guys agree? All right, so then here's what we're doing. I'm going to go, what is the limit as x approaches 0 of negative x squared? Well, I can do direct substitution on this one. I don't get a 0 in the denominator. There's no denominator. So the limit of this is, let's see, 0. And then I'm going to go, okay, what about this guy? Limit as x approaches 0 of x squared. I don't have a fraction. I can do direct substitution again. As x approaches 0, for limit as x approaches 0 of x squared, I'm going to get 0 again. So here's the logic. If sine of 1 over x is between negative x squared and x squared, and this one here converges to 0 as x approaches 0, and this one here converges to 0 as x approaches 0, then because I have my both extremes, the one in the middle must also converge to 0. And here's the image. Here's the picture of that proving it true. And this is why they call it the sandwich theorem. Here's x squared. Here's negative x squared. And notice what happens as x approaches 0. All 3 of the curves are getting closer and closer to 0. Does that make sense? And that's why they call it the sandwich theorem. So hence, limit as x approaches 0 of sine of 1 over x must equal 0 since what? Since the limit as x approaches 0 of negative x squared equals 0, and limit as x approaches 0 of x squared equals 0. And then I'll refer back to this right here. And that's perfect. Well, maybe not perfect, but good enough for me. When we get closer to the AP exam, I'll let you know how we should be writing stuff. We're not teaching to the test. We're just teaching right now to learn. Are we okay, guys? Okay, so I'm going to go to your activity. We're going to do those together because that tends to be the hardest questions for you guys. I never gave you one? How come I never give you one? You were here? Oh, yesterday. I thought you were talking about the notes.
No, but make it first post. Make it first post. It's obviously math. Ready.
No, I'm gonna change it to.
I knew I should.
I'll give you one right now, Samantha Lopez. I just don't know where they're at. All right, guys, here we go. Ready? So here's how I would do this. You see this sine x? Yeah, number 6. I'm at number 6. I'm going to go sine x. What's the biggest sine x can be? So I'm going to put less than or equal to 1. What's the smallest sine x can be? So negative, hey, relax. Why do you say it like that? Negative 1. So I know that sine x is between negative 1 and 1. Are we clear? Okay. But they don't want to know the limit of sine x. They want to know the limit of sine x divided by x. So I'm going to divide this by x. Whatever you do to one, you do to the other. So there it is. What's up? Because it's a wave, and sine x goes like this. And the biggest it is 1, and the smallest it is negative 1. You're good. Oh, okay. Actually, I might use that space, but okay. 1, negative 1. Those are y values, right? Right? Okay. All right, here we go. I'm going to try to fit it all in here. So I'm going to look at both extremes, these two that I'm circling. So I'm going to go limit as x approaches, what do they want? Infinity? As x approaches infinity of negative 1 over x. So think about it. Negative 1 divided by a huge number. What is that going to approach? 0. Good job. You guys did it. You guys are becoming pros. This one right here, limit as x approaches infinity of 1 over x. So 1 divided by a huge number. 0. Okay, think about it. If limit as x approaches infinity for the leftmost extreme is 0, and the limit as x approaches infinity for the rightmost extreme is also 0, then therefore the limit as x approaches infinity for sine x over x must also be 0. And that's good enough for me. If I see this like this, I will give you full credit. Like, oh yeah, they do it. They did the leftmost extreme. They did the rightmost extreme. So then that must equal 0 because of that. As we get closer to the exams, I'll let you know how you should be writing it. We're not teaching to the test. We're just teaching to understand. Are we okay? Okay. Now we're doing the same thing with this. So let's see if I can fit it here. 1 minus cosine x, the biggest. So think about cosine x being inverted and shifted up 1. So what's the biggest cosine x can be? No, not 1. Not 0. The biggest. You guys know what I'm talking about? Yeah, I heard someone say it. What is it? 2. What's the smallest 1 minus cosine x can be? 0. Guys, it's just a wave. It's just doing this. Here's my axis, and it's just going like this. Here's 2. Here's 0. Because remember, the midline is right smack in the middle. So from the midline, you go up 1. From the midline, you go down 1. Yeah, remember, this is why pre-cal is important. So make sure that you know your pre-cal. It's not even extreme pre-cal, just a little bit. All right. Again, what am I going to do? That has an x squared on it. So I'm just going to write x squared. Whatever you do to 1, you got to do to all of them. Again, on the left-hand side, 0 divided by anything is 0, but I'll just do it again just in case for formality. Limit as x approaches infinity of 0 over x squared is always going to be 0. Let's look at the right-hand side. The 2 over x squared, limit as x approaches infinity of 2 over x squared, that's always going to be 0. Well, okay, not always, but as x approaches infinity, the limit will be always 0. Okay, so because the leftmost extreme is 0 and the rightmost extreme is 0, therefore the one in the middle must also equal 0. For now, this will suffice. Cool or not cool? All right, I don't see any other question that would give us an issue. Okay, I think we're good, guys. We got, how much time we got? Oh, no, we're done. Actually, we're done. Pack it up. I think we leave now.